Welcome back to this course on regular expressions. In the last video, we got our Python environment set up for using regular expressions, and we demoed it with some string literals. But as we said last time, matching with string literals is something that we don't actually need RegEx for. So in this video, we're going to take our first step into learning some regular expression syntax that will allow us to create some more complex and flexible patterns. And to start, we're going to look at the concept of metacharacters. Before we begin, I'll note that I'll be doing my demonstrations exclusively in Python from here on out. But remember, you can always be following along on RegExer to test out the patterns that we're doing, test out your own patterns, and develop a more intuitive understanding of the syntax as we go along. So with that in mind, let's take a look at the first important metacharacter in RegEx syntax, the period. In regular expression syntax, the period is essentially a wildcard character, meaning that it can match any single character except for a new line. So to give an example, if I were to call the regex search function with my pattern as a period, it should give us the very first character that's not a new line in the string. So I will try that out to demonstrate. So my pattern is going to be just this period metacharacter, and we're using our same data string that we had last time. And I will access the group of that search. And here we go. So if we recall, the first character in our string is this capital W. And so if we search for the first occurrence of this period metacharacter, it will give us the very first character that's not a new line. So that's all well and good, but regular expression metacharacters really shine when you combine them with other characters. So let's say, in our string example here, we want to extract every substring that has one character after the letter T. This would be fairly tedious with typical Python string methods, but with regular expressions, it's very simple. All we need to do is add a T before our period metacharacter. And so if I do that, it will yield a pattern that has a T and a wildcard character after it, meaning that this will match any pattern in the string that has this form. So rather than having this in a search function, we should try find all so that we can see all of the different matches that we get here. So remember that find all returns a list, and so we won't need our group function. And let's take a look at how many matches we can get out of this pattern. Okay, so here we go. Let's go back up to the string and see. So this has matched every single occurrence of a two-character substring where the first letter is a T and the second letter can be anything we want because we use this metacharacter here. So it matched this, what else did it match? Presumably, TE, TH, TH, etc. So that is more or less how the period metacharacter works. In the subsequent video, we'll be looking at these other three metacharacters, which are used for quantification. So I hope you enjoyed this one, and I'll see you there. Hi, and welcome back. In this video, we'll be continuing our lesson on regular expression metacharacters, the first bit of regular expression syntax that we've been tackling. So last time we looked at the period metacharacter, which essentially acts as a wildcard that can match any character except for a new line. In this video, we'll be covering the remaining three metacharacters, which it turns out have more in common with each other than any of them do with the period. This is because these three metacharacters are actually quantifiers, whereas the period represents a particular character. I'll show you what I mean. Let's take a look at the asterisk metacharacter first. The asterisk metacharacter matches the preceding character 0 or more times. This essentially means that whatever character comes before the asterisk becomes optional, or it can appear as many times as you want. So continuing our T example from last time, let's take a look at a pattern that uses the asterisk. So we'll do re.findAll. And for this pattern, let's have a T, but we will make the T modified by the asterisk metacharacter. And it will be followed by an O. So in plain English, the pattern we have here is as follows. Match an O character preceded by as many T's as match an O character preceded by any number of T's, including 0. So let's throw in our data string and see what it can give us. So we can see right here that it has matched a number of O's, and it has also matched this 2-character sequence, this word 2, because we have a single T here. And so for these other O's, it's saying, okay, well, we have a single O, and it checks before it, and it's like, well, there's no T, but we have an asterisk, which means the T is optional, so it will also match these O's. This is really useful when you're trying to match string data that has a prefix or a suffix that only appears occasionally. Let's try another example to illustrate it further. I will copy this print statement. And let's take a look and see what happens if we try to match this part right here with 2 letters after another. So let's say we want to match the letter I preceded by any number of the letter S. So we will say S asterisk I. And let's take a look. Okay, and so as we can see, it has successfully matched all of the I's that have nothing before them because we made the S optional with the asterisk, but it has also matched this 3-character sequence here because we have an I preceded by 2 S's, which are also matched by the asterisk. It's important to note that one of the major differences between the period metacharacter and any of these metacharacters is that the period can stand on its own as it represents an actual character, but these require something before it in order to work. These must modify something as their quantifiers. If I were to try and type a pattern with a hanging asterisk like this, this regular expression would not compile and the program would fail. These metacharacters must have something to quantify. With that, let's move on to the remaining 2 quantifiers, which are just slight tweaks of the same logic of the asterisk. So the first one is the plus. The plus is essentially the same as the asterisk, but with one important caveat. Whereas the asterisk matches the preceding character 0 or more times, the plus matches the preceding character 1 or more times. So unlike the asterisk, the character must appear in the text for there to be a match. It is not optional anymore. So if we were to edit this one right here and replace our asterisk with a plus, we would expect that we should only get matches where we have an O preceded by a T. Any number of T's, but it must be at least 1 T. And so we can see with that, we only match the word 2. We are no longer getting these hanging O's. And that's essentially all there is to it, to using the plus. The final quantifier metacharacter that is important is the question mark. The question mark matches either 0 or 1 of the preceding character. It essentially makes the preceding character optional, like the asterisk, but it will only match one occurrence of the character, whereas the asterisk matches multiple occurrences. So to illustrate the difference here, let's take a look and see if we edit this pattern to have a question mark instead of an asterisk. Let's take a look at what the difference will be. Okay, so we can see right here the difference between the question mark and the asterisk on display. Whereas the asterisk matches an arbitrary number of S's, the question mark will only match a single S, because it's either 0 or 1. But because it's also 0, we're still getting these singular I's. One more important thing to note about metacharacters that also applies to any special characters that are used in regular expression syntax is the inevitable situation where that character itself is part of the string data you want to match. If, for instance, you want to match a literal period and not have it be registered as a metacharacter, you'll need to use an escape sequence, which, like most programming languages, is simply a backslash. So let's take a look, for instance, at matching a literal period rather than a period metacharacter. So we will find all backslash period. This should give us a string literal of a period rather than that metacharacter. And let's take a look. Okay, and we can see it has successfully matched that period. But if I were to get rid of the backslash, this will match every single character in the string because this represents any possible character. So let's take a look at that. And there we go. So we can see if we do not escape the character, it will have its meta character value. So with that, we've covered our first bit of real regular expression syntax, and we already have some quite powerful tools at our disposal. So I hope you enjoyed these videos on meta characters, and I will see you in the next one.